Hi everyone, I'm Lutz Hofmann. I'm with the Visual Computing Group at Heidelberg University in Germany, and I'm also the maintainer of the TTK Conda package. I'm going to talk about using TTK with Python. There are multiple ways to interact with TTK from Python, and for this, let's recall that TTK is organized in these three layers. At the bottom, we have pure C++ code, which is then wrapped into the VTK algorithm API, and by additional XML definitions, these are then exposed to ParaView. And ParaView comes with its own Python interface that is sometimes referred to as PVPython, and there's also a Python interface on the VTK layer, and this is what I am going to be mainly talking about. But first I would like to explain the differences between these two Python interfaces. For this, let's look at a simple example where we have a VTK unstructured grid where we would like to execute a TTK filter on. Now if we are using the ParaView Python interface, the first thing that we need to do is to get our data into the pipeline. And this can be done, for example, by using a trivial producer and attaching our data object to its client-side object. And this, however, only works if we are not connected to a remote ParaView server. Once our data is part of the pipeline, we can execute our TTK filter on it and finally fetch the data, where the last step would create a copy of the output data. If we are using the VTK Python interface, on the other hand, we have direct access to the underlying VTK filters, and we can directly set our input data object and get our output data object back. So to summarize, the ParaView Python interface modifies some global state, which is the ParaView pipeline, and it operates on the client-server architecture. The VTK Python interface, on the other hand, directly accesses the VTK objects and comes thus with a more verbose syntax. It also provides a NumPy interface that I'm going to talk about later. Both of these interfaces have their own use cases. The ParaView Python interface is mainly used to automate anything that you would otherwise do in ParaView GUI. And the VTK Python interface, on the other hand, operates on a lower level and offers a lot more freedom, and it can be used, for example, to integrate TTK code with existing Python code or to create custom user interfaces, and you can also use it within ParaView programmable filters that I will also talk about later. To install the TTK Python module, the easiest way is through Conda, where we provide a package called Topology Toolkit through the Conda Forge channel. You can also build TTK from source with either VTK or ParaView, where the build system then automatically detects the necessary Python support of your VTK and ParaView installations. If you do it in this way, you might need to additionally set a Python path to tell Python about the location of your Python module, or you can install the Python module to the correct location. A few words about the current state of Conda packaging. Packaging has the challenge that the VTK and ParaView packages are conflicting, and this is on purpose because ParaView comes with its own VTK library that is not compatible to any stable version of VTK. And the implication of this is that there are other third-party modules that may depend on one but not the other. And for the TTK package, we solved this by providing two different versions, where one depends on VTK and one depends on ParaView. And the default that you get when you install TTK through Conda is the one that depends on ParaView. And this ParaView package actually comes with a full GUI, except on Windows, where there currently is a packaging issue. You may also select the specific variant manually, as shown in these examples, or you may install TTK together with some other module that depends on either VTK or ParaView, and Conda will then figure out for you the correct version. If you're interested in the details, the way that this works is that we provide duplicate TTK packages for each TTK versions, but with different build strings that start with these two strings shown over here. So let's talk about the VTK Python interface. This interface is automatically generated from the C++ interface, and this is why you cannot find any documentation on the Python API. And the way that this is meant to be used is by reading the C++ API documentation and doing the translation to Python yourself. As you can see in this example, the two interfaces are very similar, so this translation is basically just replacing all the arrows in the C++ code with dots in order to get the Python code. The TTK Python module, of course, also works with any other module that depends either on VTK or ParaView, where a notable example is PyVista that provides a simplified API for rendering data with VTK, as shown in this example here. VTK also comes with a NumPy interface, and this interface allows you to wrap any data that is stored in NumPy arrays into VTK data arrays. And this is useful for integrating existing code that might already use NumPy with TTK. I show an example here where we define a triangle mesh by its positions and connectivity in terms of NumPy arrays. We then wrap these NumPy arrays into VTK data arrays and attach them to a VTK unstructured grid. The resulting VTK unstructured grid now references the data stored in the NumPy arrays, and this VTK object can be used like any other object. For example, you can apply a TTK filter on it. Once you have done that, the result is of course again a VTK data object, which you can also access by the NumPy interface, where you get NumPy arrays that reference the data that is stored in the VTK objects. This example shows how to efficiently use this NumPy interface since there's no data copied, but in practice you probably want to explicitly create copies of your data in order to avoid any memory leaks. Finally, I am going to talk about the use case of the VTK Python interface that I personally use the most often, and that's within ParaView inside programmable filters. These are basically VTK algorithms that execute a Python script every time they are called. And here we are actually not on the ParaView Python layer, but we are on the VTK layer. So we can directly access the VTK objects. For example, we could call a TTK filter in a loop and modify the data using the NumPy interface in between. There's also a more modern variant of this, which are called Python plugins, that allow you to define an entire ParaView plugin in Python code. And the nice things about these is that they act as any other ParaView filter, so they also work when you are connected to a remote server and, for example, when you are using Catalyst. And one thing to note is that while you can call the ParaView Python interface in these filters, you should not do that, because then you would be modifying the ParaView pipeline while it is executed. This is all from my side. I would like to thank you for your attention and would like to point you to the CondaForge Topology Toolkit repository, where you can report any bugs that you encountered when using the package, and any contributions are of course also welcome. If you have any questions, please feel free to talk to me at any time during the conference.